Hello, everyone, and thank you for tuning in with us tonight. I am joined here by Amar, Pacome, Irving, and Felix, and we will be talking to you about food waste to bioplastics, a path towards sustainability. Now, landfills are ubiquitous throughout the globe. 24% of this mass is occupied by discarded food. Alongside this is 18% of the mass is plastics, 10% of which are petroleum derived. We would like to propose a solution to repurpose this landfill mass area to commercialize and reduce the environmental impacts of the food waste, which emits methane, a gas 28 times more potent than that of carbon dioxide. And we would like to introduce our sustainable model for bioplastics production and bioenergy.
The research and application of bioenergy has been around for over 20 years now and has evolved over the decades. Initially, scientists relied on edible material and conventional technology to create bio-based products, but this approach meant prioritizing energy over food. Consequently, researchers moved to agricultural waste as a substrate, but this was not sustainable due to limited supply. Current research is now focused on microbes and how they can produce bioplastics. Our project focuses on the use of microbes to produce polyhydroxyalkanoid using food waste as a substrate. When subjected to increased light intensity, reduced nitrogen, and diversion of fixed carbon, these microbes produce small lipids which act as energy sources. We will now focus on what makes bioplastics sustainable.
Currently, bioplastics only make up less than 1% of all plastics. PHA bioplastics are also carbon neutral, marine degradable, has no toxic effects, and can be reprocessed into virgin plastic. As you can see in the first image, bioplastics have a repeating life cycle, while petroleum-based plastics mostly end up in landfills. I think we can all agree that we have contributed to food waste in our lives, and honestly, that's unavoidable. That's why we believe bioplastics are so important. It can not only repurpose food waste disposed by consumers and businesses, but also repurpose the byproducts created during food production. Food waste also has a big impact on the economy, using up around 16% of all land, 27% of all fresh water, and about 5% of the total energy budget in the US. Bioplastic can not only help us sustain our limited resources, but is also a multi-billion-dollar industry with a lot of potential.
The biodegradability of PHAs are what's most important. These polymers can decompose much better than conventional plastics. PHAs contain chiral molecules, so their degradation can vary based on the way it was formed. However, under the right environmental conditions, it can quickly degrade. Carbon substrates are the reason production costs of bioplastics are so high. However, as dairy, water, and solid wastes are incorporated into PHA development, the cost will decrease and bring in revenue from from waste treatment. The biocompatible properties of PHAs allow it to be blended with other natural and synthetic materials, expanding their capabilities. Some blends can be used to make rigid thermoplastics, while others are so intricate that they can be used in human skin regeneration.
There is a lot of benefits behind food wasting and producing bioplastics. First, biotechnology easily facilitates the fermentation and reduces the cost of production. Second, and most importantly, bioplastics nowadays are new dental tissue regeneration in humans. Finally, the PHA as a precursor for biofuel will help reduce greenhouse gas emissions. The image on the right side shows the different ways of the use of bioplastics.
Thank you for joining us tonight, and have a wonderful rest of your day.